All right, AP Stats students, this chapter is going to be totally different than anything you've ever done in math class, probably. So, we're going to talk about surveys and experiments and all sorts of very, very important statistical things. This whole chapter will be about 10 to 15% of the AP test. There's always at least one free response question on this stuff, and it's pretty important. So 4.1's on sampling and surveys. 86% of teens say they enjoy school. The percentage increases to 89% for females, which means the males would be a little lower. And that's from the stagesoflife.com. So, did you answer this question for the website? Well, of course you didn't. So, where did this statistic come from? Well, they try to create a good sample of people, a lot of different people, that would represent the entire population. This statistic represents you because you are a teen, yet you probably weren't a part of that group that came up with the statistic. So we have population in this statistical study is the entire group of individuals about which we want information. A sample is the part of the population from which we actually collect information. We use information from a sample to draw conclusions about the population. Identify the population and sample in each of the following settings. The student government at a high school surveys 100 of its students at the school to get their opinions about how it changed the bell schedule. So the population, all students at that school. The 100 of the students that they ask about is the sample. So the 100 students at the school. The quality control manager at a bottling company selects a sample of 10 cans from the production line every hour to see whether the volume of soda is within acceptable limits. So the population is all soda cans produced at that facility. The sample is the 10 cans. Okay, easy enough. So a sample survey. Each month, the conference board takes a representative sample of 5,000 households and asks them 5 questions about their appraisal of current business and employment conditions and about their expectations regarding business conditions, employment conditions, and total family income 6 months from the time of the survey. For each question, there are 3 possible responses: positive, negative, and neutral. These are combined into an index that is calculated relation to the value of 100 in 1985. In May 2010, the index stood at 63.3, which was weak with respect to the historical levels, but an improvement from the previous months. So we want to take a sample, ask questions, and evaluate and measure your results. So there's a nice little thing. So the sample was 5,000 of these households. They asked the questions. There is 5 different questions about all these things, and then they measure the results at 63.3%. How to sample badly. So a convenient sample is not a good sample. This is choosing individuals who are the easiest to reach. So an example of a convenient sample would be the first 10 people that you see, you ask a question. That would be convenient but very biased. A voluntary response sample consists of people that choose themselves by responding to a general appeal. So, an example of this would be like your talk show. They say, call in about how you feel about blank. That would be a voluntary response. This voluntary response is biased towards people with strong opinions. For example, if we said, call in about how you feel about the speed bump in the middle of town, well, the people who don't care about the speed bump aren't going to call in, but the people who hate the speed bump are going to call in. So whoever has a strong opinion is going to choose themselves to respond to this survey. So bias. A survey design shows bias if it systematically favors certain outcomes. So just like what I was talking about on that last one, sampling bias would be like the above. There's a lean towards certain people being sampled. So I just told you a sampling bias from this voluntary response. Undercoverage occurs when some group in the population are left out of the process of choosing the sample. So undercoverage would be like if you're trying to ask everybody through email something, well, you're leaving out all the people without email. So that's systematically leaving people out. Response bias is my absolute favorite one. This is when people don't want to respond truthfully. So, for example, I love listing these off. If you were to ask a student, when was the last time you did some illegal drugs? Well, they're not going to want to say. Like if a police officer asks somebody when they did something illegal, or there's certain things that you don't want to tell people. Maybe you have something weird about yourself and you don't want to say it. I know I do. But things like that. When was the last time you pooped your pants is my absolute favorite one. Non-response bias occurs when an individual chosen for the sample can't be contacted or refuses to participate. Non-response happens a lot. Like all those times when people say, hey, do you have a few minutes to do this survey? And people just hang up on them. Well, they're not getting a response. So this is kind of similar to this voluntary response. The people who feel very strongly are going to answer. The people who don't really care are not going to. And question bias is when the question leans towards a certain answer. So I have some good ones that we're going to do in class together. Typically, with the question bias, the more you say, the more likely you are to bias the question. So if you give a lot of background information, you say that these poor gorillas are living this horrible life. Do you support not killing gorillas? Well, everyone's going to probably say yes, or something like that. You see how the question kind of favors me saying yes or no, or whatever. So, when describing bias, you should explain why there's bias and how it influences the results. This and is what people forget most of the time. So, the words above are not as important, they're just there to kind of help you, but you should say, explain why there's bias and then how it's going to influence. In May 2010, the LA City Council voted to ban most travel and contracts with the state of Arizona to protest Arizona's new immigration enforcement law. The LA Times conducted an online poll that asked whether the city council was right to pass a boycott of Arizona. The results showed that 96% of the 41,068 people in the sample said no. Does this result represent opinions of all LA residents? And explain. So you need to explain why there's bias. There's a lot of different biases here. You could say there's voluntary response bias. You'd explain that there's bias. You would say people chose themselves for the survey, so the people who are saying no are going to be more likely to answer or choose themselves for the survey. You see how I did explain why there's bias and how it influenced it towards no. Another one is undercoverage. So again, we don't have to say the word, we want to say, since they did this online, people who don't have the internet or surf the internet will be missed out of this survey, and those people may say, they may be more likely to say yes or something like that. Okay, there's two. I'm sure you could come up with more. How to sample well? Well, random sampling is a way to sample well. So random. We use random all the time in our lives in our speech but we don't use the word random correctly. What it means is that every outcome has an equal chance. That's enough right there. I could say more. So every outcome has an equal chance of happening. Okay? Random sampling uses a chance process. That's something we're going to hear a lot to determine the sample. So we're not just picking what people say randomly, like, because it's not usually random. This chance process means that you have to do something that happens by chance. You don't use your mind. So some chance processes are going to be down here, like this random digits table. I'll talk about that in a second. So a simple random sample, SRS, is going to be an abbreviation we use a lot, of size n consists of n individuals from the population chosen in such a way that every set of n individuals has an equal chance to be the sample actually selected. So not only does every individual have an equal chance of being picked, but every sample, so every set, every group, if I want to use a third word, has an equal chance of being sampled as well. Every individual has an equal chance of being selected, and every sample has an equal chance of being selected. So a simple random sample does both. So a random digits table is a great chance process that's going to work. We don't use this that often. We're going to go through a couple examples because the AP test really uses it. There are better ways. So each individual is given a number of the same length. For example, for jelly bubblers, 1 would be 0, 1, and 100 would be 00, so that you have 2 digits and 2 digits. Use a selected row, and you count every set number of digits and select that individual, ignoring repeats. I'm going to go through this in class with you, so don't worry too much about it. Using a random number generator, each individual is given a number. There's a common theme here. And you generate n integers between 1 and p. And p is the sample size, also making sure to ignore repeats. Okay? So the management company at Tuttle Mall plans to survey a random sample of 10 stores to determine the hours they would like to stay open for the holiday season. Describe how you would get a sample of 10 from the 120 stores at Tuttle Mall. Well, I'm going to use a random number generator. So I'm going to give every store a number between 1 and 120, and we're going to choose the first 10 and ignore repeats. AP test tip. A lot of people say this first part, but they forget to say ignore repeats. It's going to knock your score down. So let me show you how that's going to look in your calculator. So you're going to go to Menu, Probability, Random. I'm going to do Random Integer. Okay, because integers, remember, are 1, 2, 3, 4, 5. They're kind of like whole numbers. They're positive and negative. So an integer from 1 to 120. So there I could get one at a time. There's 114, 109, 18, 62, 49. None of them repeated, so I don't have to throw any out. What if I want to do 10 at a time? Say comma 10, and that will give me 10. 89, 6, 41, 120, 25, 96, 115, 27, 45, 1. None of them were repeated, so we got all the ones that we needed. The first 10 unique numbers, and that would be my sample. I would sample those stores. Other types of sampling. So sometimes random sampling doesn't meet the requirements. Let's say Mr. Matage wants to form a group of 10 students. Is it possible that he could randomly pick a group of 6 seniors and 2 juniors, 1 sophomore and 1 freshman? Well, yes, that's possible, but is it likely? I don't know, maybe. While the group was fairly chosen, he has a problem with this group. How could he choose a group that is more representative of the school population? Well, maybe we want to get 2 seniors, 2 juniors, 3 sophomores, and 3 freshmen. Maybe we want that's a little more even. We can do that. So what we could do is we can do what's called a stratified random sample. To select a stratified random sample, first, we classify the population into groups of similar individuals divided by some characteristic called strata. So in our example, the strata would be seniors, juniors, sophomore, freshmen. We would stratify them based off of the characteristic of what grade level they're in. We could also stratify by gender, by race, by a lot of different things, by age. All of those are pretty common ones. Then we choose a separate simple random sample in each stratum and combine these simple random samples to form the full sample. So that's what we just did. So once we picked our 2 seniors, we would ignore the rest of the seniors. Once we picked our 2 juniors, we'd ignore the rest of the juniors. Same thing with these 3 and 3 until we have this group that we wanted. A way that we did this at school is we looked at test scores and we wanted to group people who were in accelerated classes versus non-accelerated classes versus students that repeated that class for the second time. We wanted to look at different subgroups. It gave us better data. A cluster sample is a little different, and these two get mixed up a lot. So to take a cluster sample, first divide the population into smaller groups. Ideally, these clusters should mirror the characteristics of the population. Then choose a simple random sample of the clusters, and all individuals in the chosen clusters are included in the sample. So an example of this, if we're doing our school again, would be if I were to sample a lunch period. If I would randomly choose one of our 3 lunch periods, 4th, 5th, or 6th period, and then we would sample every single student at that lunch period. Or we would randomly select a study hall, and then we would go into that study hall and we would sample all of those people. That's why this all individuals in the chosen cluster are included. Okay, so these two get confused by some people. Stratify, you group according to characteristics and pick a sample from each group to get a final sample. And in the cluster, you grouped into similar grouping and you randomly select to get a final sample. Okay, so in this one, you're picking from each group. In this one, you have mixed groups. The stratified would be your homogeneous groups, and your cluster would be heterogeneous groups. Okay, remember homo means same, hetero is different. There's a little biology connection for you. I have one good example that kind of does all of this, the auditorium example. The student council wants to conduct a survey during the first 5 minutes of an all-school assembly in the auditorium about the use of the school library. They would like to announce the results of the survey at the end of the assembly. The student council president asks your statistic class to help carry out the survey. There are 800 students present at the assembly. A map of the auditorium is shown below. Note that students are seated by grade level and that the seats are numbered from 1 to 800. The 12th graders are seated from 1 to 200. So we have 1 to 20, then 21 to 40. So the seniors sit in this front row. The juniors sit from 201 to 400, so the juniors sit behind them. The sophomores sit in seats 401 to 600, so they're right after that. And the freshmen seat in seats 601 to 800, so this last row. So if we wanted to do a simple random sample, we would randomly choose numbers from 1 to 800, so we would use our rand int for integers from 1 to 800, and we would pick 80 of them. Don't forget to say ignoring repeats. The stratified random sample is going to be easy in this situation because we already have our 4 strata. To get a sample of 80, randomly choose 20 from each grade level. In a cluster sample, we would choose a row. If I chose row 1, I would have some seniors, some juniors, some sophomores, and some freshmen. And I would sample every single person in that first row. So that 1, 21, then it would be 41, 61, but that would only give me 40. So I'd want to randomly choose 2 unique rows and sample every single person in that row. And that should make some sense.